Hello, in this short video we'll be showing you how to use some navigational aids such as GPS, NDBs and ADFs. We'll also be showing you what is contained within an URSA and how to use a flight plotter to calculate the heading and distance of your destination. When first preparing for your journey, the first thing you should do is look up your destination in an URSA. An URSA can give you some of the following information about your destination: aerodrome code, aerodrome obstacles, lighting of runway, elevation, what type of fuel they supply if they supply any at all, charts relative to the aerodrome, location, radio navigation, landing aids, local traffic regulations, passenger faculties, and they also supply additional information for certain aerodromes. So as you can see, the URSA can supply you with some life-saving information. When starting to prepare, there are some key pieces of information that you would need to fill out the flight planner, like TAS, wind, track, magnetic, aerodrome code found in the URSA, FL or ALT, and LSALT. Using a navigational plotter, you will need to find the heading and distance. Using this previous information, you will be able to find the ground speed and ETI and EET using a flight calculator. I will now show you how to find the heading, magnetic, and the distance from your aerodromes. First off, place the left-hand side at your takeoff aerodrome and move the other side over your destination, so the edge of the plotter makes a line going from aerodrome to aerodrome. On this map, it is a consectional scale, which means we'll be using the consectional ruler to find out our distance. Nextly, move the sphere around until the arrows face up parallel to the longitudinal lines on the map. Now, where the rectangle and circle meet, this will give us a heading to our destination. When arriving near your intended aerodrome, there has been some pieces of equipment placed in most aerodromes to help the pilots find their destination. These pieces of equipment are known as navigational aids. Some of the navigational aids are extremely helpful. We will now go into more detail about each aid, starting with NDBs. NDBs, or non-directional beacons, are radio transmitters placed at some aerodromes. They transmit radiate energy in all directions. The piece of equipment placed in the aircraft to latch onto the signal emitted by the NDBs is called the ADF, or Automatic Directional Finder. The ADF is the instrument that can show the pilot the way to the aerodrome by displaying a yellow arrow on the gauge shown now. Another navigational aid used a lot by IFR pilots is the VOR, or Very High Frequency Omni Range. The VOR is used by IFR pilots to track their way towards or away from the radial that is located at some aerodromes. Although the VOR is very useful to IFR pilots, it does not tell the pilot which direction they are traveling. Another more commonly known navigational aid is the GPS, or Global Navigation Satellite System. This consists of 24 satellites orbiting the Earth in 6 different planes. There are 3 spares while 21 are active. They consist of 3 different segments: the space segment, the control segment, and the user segment. So how does the GPS work? The GPS uses the known position of as many satellites as it can be acquired, and then computers an ST fix based on their range, calculated from the elapsed time of the signal. The receivers compute a 5-second sensor, a possible time error, and immediately begins a trimming process until it arrives at the answer, which allows all ranges to arrive at one and only one position. The last navigational aid that we'll be covering in this video is the DME, or Distance Measuring Equipment. The DME is designed to provide continuous indications of an aircraft's distance from a selected DME ground station. A frequency between 960 MHz and 1215 MHz DME operates similar to the radar. The DME transmits a continuous series of radio pulses, known as interrogation pulses. The ground station will reply if the signal is accepted.